Okay, and we're live. Thank you guys very much for joining us. This is the weekly podcast that I've been doing with Brian from Futuraza, from Hans at Hans C. Nelson, and of course, Scott Walter, two-time robotics founder. The biggest topic or question that people have is what is Tesla's advantage when it comes to a humanoid bot? And we'll walk through all the different kinds of ways to evaluate these different bot manufacturers. But the big one, of course, is Tesla is known to be able to manufacture at scale. Let's dive deeper into that and just kind of understand where it is exactly Tesla is, what kind of jobs that they're hiring. We got a whole list of them, and what is that they can do to give them that significant advantage, or maybe it's not. Right? Let's explore that. So, let's kick it off with you, Scott. What is your kind of just thinking of how you want to frame this conversation?
Well, the first thing, of course, is there's the idea of being able to, design for manufacture, which is something every engineer is taught to think about. Can you actually build that thing, and you don't build some impossible object that you realize, oh, we're not going to be able to build this thing. But a lot of times it comes down to it's like, well, can I actually take it down to the shop and actually manufacture this thing with CNC machines? It's got to have two halves or something like that. That's one part of it. The other, of course, is can you design it efficiently and rapidly? What would be the steps to go on there? And there's got to be this nice iterative loop between picking your materials, your designs, how everything's going to come together, and thinking about what's going to be the ease of design, what's going to be the ease of engineering, and getting the two in there. So it's one thing to understand it in theory and from the textbooks. It's another one in practice. So I'm sure that if you think about the very first roadster that Tesla came up with, they thought it would be so easy to buy someone else's and just retrofit. And then they realized, oh, it doesn't work that way. That's not so easy. You have to think a little bit differently about how to do it and start getting into the manufacturing. They've gone through so many different generations of different products, realizing what the ramp ups are like and how difficult it is. You need experience. And the more experience you have, the better you are at design for manufacture. You won't be that good at the very beginning. You will get it all wrong at the very beginning. And then you will go through those steps to try to improve that. And then there's going from design to manufacturing to DFX, which is design for excellence. So not just being able to make it, to build it, but build it with like extreme quality, and that everything about it is just like really thought through. That's something that comes from iteration and iteration. And of course, the other thing is like, well, not just design for manufacture, but what about scalability and affordability and all those other things that have to come in there? And these things are always at odds. They're pulling in different directions. You've got to figure out, how do I pull them in here so I can build this cheaply, I can build it efficiently, I can build it at scale, and the thing actually works. So you've got to take all those into consideration. And then there's that balance between, am I low scale production, medium scale, or large? If you're small scale, you're going to go full manual. If you're extremely high scale, you're going to just automate everything out of it as much as you can. And if you're somewhere in the middle, you're going to have automation where you need the automation, and you're going to have the manual where you need the manual. So you have to really understand how many of these units you're going to pump out when you start deciding, okay, now I've got to start building my lines. And if you don't know what that is, then you could make the mistake of producing more product than the market wants, or not producing enough. And now you're going to think about, well, how do I double my scale? It's not going to be so easy as just make my conveyors run twice as fast. It's going to be, oh, we're going to build another factory.
So on that, I would add that for those who don't understand the whole thing about design for manufacturing, what you've got is look at a concept car. They're beautiful. They are pretty easy to make compared to actually producing a car. And part of the reason for that is because you don't need dimensions that are actually practical. You don't need a window that actually rolls down, that will actually fit in the door. When rear doors got small enough that they could no longer roll down the windows, they had to decide, do we make the windows shorter so it goes all the way down and then put a little bar in it, or do we make it so the window only goes part way down because the door just isn't big enough? And when it comes to actually building something that you're going to scale, what you're talking about is that when Tesla started, they made a lot of rookie mistakes in manufacturing. And that's to be expected of any new entrant into any industry. So when you look at someone like Tesla's move to robotics, they're going to skip a lot of those big obvious errors that someone like Boston Dynamics couldn't. If Boston Dynamics wants to go wide with Atlas, they're going to struggle to get to scale because they've never built anything at scale. Everything they build is at very low volumes, and there are a lot of painful learning lessons there. And Atlas was never designed to be manufactured. It was designed to raise the next round of funding, and it was very successful at doing just that and just that. So there's a lot of lessons that are going to be learned. You got to realize that um, Hyundai now owns Boston Dynamics. That would give them an advantage in manufacturing, but we don't know how much integration there is between these divisions. Where we know with Tesla, integration is something they do extremely well. So in that regard, yeah, making something so that it can actually be built and actually be built at scale is very difficult. That's the whole thing about prototypes are easy, production is hard. You've got different departments who are all fighting for the same real estate inside the car. I want my battery management system here. Well, you can't put it there. The hood hinge is there. Well, okay, then I'll move it over here. Sorry, the cooling guys already have that space taken up. And pretty soon you've got a car with no frunk, which is what we've seen from all these manufacturers that don't have their integration quite as tight.
Yeah. So
All right. So let me.
Yeah, just 1 second, Herbert. What I want to do, just to go back on the design for manufacture, just give a good example here. I'm an engineer and I decide I need to build a stainless steel sphere, which is hollow in the middle. So I just design it and it's like a sphere and it's hollow in the middle. Now make that for me. Well, okay, how are we going to make it? Because we can't make it as a solid sphere, right? We're going to have to make two halves and we're going to have to figure out. But no. It's going to be solid. I don't want a seam in there. I don't want to have any nuts and bolts on it. And so you're looking at it and said, okay, you can design it, but it's not manufacturable. Or is it? I mean, it used to be that it wasn't manufacturable, but now we have 3D printing. And with 3D printing, some of the things that used to be difficult to manufacture, you can. So you've got to understand the manufacturing techniques that are available today, not just from yesterday, won't be going forward. So sometimes you might want to design something that looks really hard to manufacture, but it may turn out there's a way to do it. So that's why we're saying design for manufacture is one thing to say, I can build something in my machine shop. And another thing, whether it could be built with more sophisticated automation and understanding what is possible today and not. And sometimes designers don't understand how things are built on the floor. If you don't understand how it's actually built on the floor, it's hard to do it. Why do you think all the Tesla engineers have their offices on the floor?
It's because of that exact thing.
Yeah, exactly. So
Okay.
sorry about that.
So I want to, I want to share something that I think is a very important fact that we haven't seen yet, which is, as we know, as you guys have described, Tesla's manufacturing, that is their skill set. They've created this, but they've been hiring all these job openings for Tesla and specifically manufacturing jobs. Let me show you that because it's quite interesting. So we've shown this a long time ago. And what I've been showing on the screen here was the evolution of the bot. So not only is Tesla's humanoid robot is kind of designed, Gen 2, it seems to be ahead of the others, but they've been hiring manufacturing jobs for quite a while. This is an old job listing. You can see manufacturing here. These are the engineering line leads. This is an engineering technician. They're already creating the line. But watch this. This was a month ago, February 7th. Alexandra Mertz, Tesla Boomer Mama, has been doing an amazing job keeping us updated on all the job openings. And she's been keeping a close eye on the job openings for the bot section. 112 jobs. 112 jobs in the bot section, Palo Alto, just last month. Just incredible. Watch this little clip here that she put together. And as you scrolls down this list, there's Autopilot Robotics. So they've combined the Autopilot and Robotics teams into one. You see manufacturing peppered throughout this as well. And then you'll see engineering and so forth. So why would a company be hiring hundreds and hundreds? This is just this, where it is now, of people in this job, specifically these openings, if they aren't already planning at the very least. You got manufacturing here. You've got engineering and information technology, and of course, autopilot and robotics. Manufacturing again. I mean, this thing is just keep going. This list just keeps going on. Isn't that crazy, guys? I mean, it's amazing that they've been hiring this many people specifically for the bot program. And then the other thing I want to quickly share here is that a while ago we knew this, which is Tesla was hiring for the night shift. So they, includes one weekend day. Why do they need a test engineer for night shifts and weekends? If you know what I mean, like, what do you guys think?
You do
I mean,
that when you're in a
obviously-
I
hurry.
agree with you completely.
One at a
Yeah,
time.
what I was saying there is that the idea is that the engineers have a new thing, they're doing their new thing, and then they hand it over to the testers so that by morning when I get back refreshed, we've got a whole pile of data to sift through and we find out if the new thing worked. So having testers overnight cuts down your schedule, your timeline, cuts it in half realistically, I would think. Guys?
Yeah, I was just going to say, it's because you're in a hurry. I want to get stuff done. I'm on a schedule. I mean, I don't want to wait 12 months. I want to get it done in 6 months. So that means you don't wait. You get stuff done
you guys-
24 hours.
Did you hear the couple points? One was Morgan Stanley. They made a note and they said that they've been hearing that Elon has been spending more time with the Optimus and the bot program. And then Chris Camillo, who has invested in multiple humanoid bot companies, he came out and he said something like that as well. He's heard from his sources that Elon has been spending more time. Now, this is just hearsay. We don't know what this means, but it makes sense that they would focus their attention on the humanoid bot, make that happen. Now, just to remind everybody, Elon did say in the last earnings call, he said something like, we expect some number of Optimus to be shipped to customers next year, 2025. That's what the words he used.
He didn't say customers.
Oh, shipped. You're right.
Shipped.
But I assume when he said the word shipped, I asked everybody, what does that mean, shipped? And everybody said it means customers. It doesn't mean just themselves. What do you think, Hans?
If he meant customers, he would have said customers. So he didn't say customers, and that means we don't know if it is or is not customers.
But
It could very well be. Like, I think that unless you want to call Giga Mexico or Giga Austin a customer, in which case then yes. But it's hard to tell what the overall evolution of this thing is going to be. And we know that there's thousands and thousands and thousands worth of Optimus jobs to be done with inside of Tesla long before it needs to go outside to continue the development of the program.
Yeah.
Well,
so that means
I would take a middle ground and say that it's possible that that shipped could mean to other Elon companies. It could mean the Boring Company or SpaceX. That is leaving the shipping dock. That is leaving the books as a saleable or leasable item, while still being kind of in the ecosystem. So that would be a middle ground, because to me, shipped means you're collecting revenue on it, and internally you would not necessarily do that.
He did also say he referred to Optimus as a product 3 times. Called it a product 3 times.
Yeah. And I was going to sort of I had the same thought as Brian, but I was going to go more with ship could mean it won't be in Palo Alto, but going outside of Palo Alto within it, because sometimes organizations have internal customers depending upon how accounting and everything like setting up. I have a feeling Tesla is not quite that way. Between the Elon companies, yeah, they have to do it that way. So if they're shipping something to SpaceX, that really then goes on the books as some sort of transaction. Internally, there's going to be something to say that, yeah, that kind of goes off of that guy's budget over there because it's costing us for, either for CapEx reasons or OpEx reasons, that we kind of look at it this way. So we don't exactly know what it means. And again, as someone did commented, there's the other possibility that could be going to suppliers, but I'm not sure it would go to suppliers right away. It will eventually. It makes sense to go down into the tier level, but you got to make sure it's actually working functionally for you, unless there is some supplier that has the best of the low-hanging fruit. And they're just like, yeah, we'll go ahead and send them there. But
All right.
shipping does imply one thing, and that is production.
Production. Okay, so Scott, let me just straight out ask you the question, right? You and I have interviewed quite a number of humanoid bot companies. We've studied them quite closely. You and I have done 40 plus videos on this channel. And so we, very well how these bots are manufactured, what stage they're in. Tell me what you think is Tesla's advantage, and how could other companies partner or create their own factory, and how long will it take for them to manufacture this?
Well, first, it comes down to that Tesla already has experience on building complex products and shipping them numerous times and everything that kind of goes through with it. So that's like one advantage that they already have. They know how to actually build a complex product. This is a less complex product. Still get complexities in there and some challenges, but things that are well within their wheelhouse that they would be able to handle. The other thing is that manufacturing is not just having a factory and not just having it built up, but understanding the supply chain and the how long you have to the lead times you need to be able to get the equipment in, all the suppliers you need to have, being able to negotiate really good prices. I mean, that's something that Jeff Lutz would go down on and on about what that's like, and it's something that you have to set up at a very early stage, so you don't suddenly get your prototype up and working and say, oh, okay, now we're going to pivot and start manufacturing. You want to get some of those personnel in early stages, which is probably why we were seeing a lot of the listings there, to start thinking about these things, to start dealing with their suppliers, because there may be a couple of items there that are long lead time. Some that you might be able to order today and literally get it tomorrow, but others could be 6 months or more. Because we know with the Giga castings, that's a really long lead time. And so knowing that's this huge moat that Tesla has, is now that everyone realizes, hey, these Giga castings, what a great idea. Let's go into Amazon and order one. They begin to realize, wow, how many years do we have to wait before they're going to be ready? So there's the potential there's going to be some items like that. And if you haven't gone through that, if you haven't gone through that production hell once or twice, well, you're about to go through production hell.
Can I show you guys this? I just found this. This is pretty cool. This is really cool. Watch this. Giving you guys a little bit of a. What do you think, Scott?
Okay, so I'm trying to remember this part of it where they were looking at the powertrain versus the robot, and I think they were looking at this is more like a simulation or engineering study, right? They were trying to figure out exactly probably the modes of vibration of the bots, what it's going through for crash testing purposes. I'm trying to remember that. And yeah, so if I recall, what they wanted to do was, in order to optimize the bot, they had to understand all the tasks the bot was going to go through. So you had to have like forward motion, walking, sitting down, picking up an object, etc. And there's a lot more tasks or operations that the bot has to do versus a car.
Exactly.
The car, you're more or less worried about just driving down the street. Yeah, it's far more complicated.
Okay.
And so that was like the study that they had to do to figure out what are the optimal servos that they need. How much motor torque do you need at all your different joints to be able to perform certain tasks? And then that's where you decide on that task list what you need to do. So if you look at it, I think being able to do, lunges and backflips and parkour was not on the list. So you don't want to, it's intentionally they're saying that, which means that if it is on the list and suddenly, whoa, those motor torques are going to have to go up a bit more. In order to do it, for the same reason that for not every human can do backflips, because a lot of us we don't have the muscles in our legs, or maybe we used to, but we don't have them anymore. So you need to get them up to a certain level to be able to do some of these tricks. So if it's just normal walking, carrying, and only carrying like a 50-pound load as opposed to carrying a 150-pound load, that's going to tell you what it is. So you optimize your design. And then once you verify that it works, you can say it's design locked. We can now start going in manufacture. But remember, what they're doing is that they have over 40 actuators. I think it's now 42 actuators throughout the whole bot. So do you want to have 42 SKUs? That's a lot of different motors that you have to produce from different suppliers. Or do you want to limit them? So they went down and said, how many of these servos can we use in multiple places? So rather than having 42, they only have 7 now. They have 6 of the main actuators for the main body, and then they have the one for the hands. And again, the hands, they need a total of 12 actuators, and they're all the same. So again, limiting your SKUs means manufacturing is a lot easier, fewer lines, and the greater the volumes you can get out of those lines. Again, that drives your cost factors down.
Can you explain that a bit? Because that's important, right? You're saying that the most expensive part of creating a bot for all humanoid bots is going to be the actuators. Because if
Yeah.
you need 40 of them and it costs you $1,000 to make per actuator, it'll be $40,000. And so you need to lower that as fast as possible. Everything else is not going to be as expensive as the
Right.
actuators.
So,
Can you explain
so I
that?
did a bill of materials of here. Well, what's going to go in the bot? And anyone can sit down and do this exercise. We know it needs cameras. We know it needs batteries. We know it needs actuators. It's going to need some sort of castings for holding together. There's going to be some miscellaneous hardware. You can go through and come up with any sort of thing that you want, but eventually you'll boil down that list and you go, oh, what kind of cameras in there? Well, they're the same cameras that I have in my cell phone, right? And they're pretty cheap, and especially if you're a company like Tesla, you're able to buy them in bulk. They're already cheap. Oh, batteries, they must be expensive. So I went into Amazon to figure out how much the batteries are going to cost. Based on the size of the battery pack they're going to put in there, if I was to buy the batteries from Amazon, they could deliver it to my door, it would cost me $800. That's when I did the calculation about 12 months ago, right? Since then, the price of batteries has gone down. And second, Tesla doesn't buy them from Amazon. They buy them internally from Tesla. And if you also look from what are the latest cost per kilowatt hour per kilogram, those costs is like, it's well under $100 now. You just do that calculation and the batteries in Optimus is like $300. That's nothing. Okay. Everyone would think that's an expense item. It's a big expensive item in the Model Y, let's say, and the others that, it seems to be, but for Optimus, it's nothing. And then you look at the cameras and everything, and you try really, really hard. Just throw the actuators out. It's really hard to get in the thousands of dollars for your components at that point. It's really, really hard. So if you want to say, oh, let's just say everything, save the actuators, is $10,000. And I'm sure you could do all that for 10 grand. Now we got to look at the actuators, and that's where you're right. We've got 42. And if we don't know how to build them at scale, that could be costly. If we can build them for $100 a piece, that's $4,000. Then we're under $15,000 for building the bot. If it's $1,000, it's $2,000, then we start getting up to the $100,000 range. But let's look at it. Brian, I'll ask you, the new Model 3 that they're coming out with has a drivetrain in the back, right? With a motor that has like lots of torque. And it's got the housing and everything. And how much can Tesla build that for?
I would guess it's at about 2,000 to 4,000 at this point. It's already gotten very, very cheap.
I thought they said that it was like 2,000 and they're aiming for the next one to be like 1,000 or something like that. Because
I would have no problem believing 2,000 on that.
Because I think that's what was mentioned, I think last February. Remember they went through and did a breakdown? They said something about currently 2,000 and that they plan on getting it down to about 1,000. And that
was the goal for the motor shop for the next generation vehicle. Like the new, it'll be permanent magnet, but not using rare earth elements motor.
Right. So if that's the worst case, it's like, okay, come on, they can build all these Optimus actuators for at least $2,000, right? So it's like, oh, it's $80,000 right there. Okay. But they're not as complex as that.
So one thing I would want to point out that is a big difference between the Tesla's approach and anyone else's approach is when Tesla's looking at using cast parts, a lot of other manufacturers, especially at low scale, are looking at using CNC milled parts where they start with a block of aluminum and mill it into the shape they want instead of casting it. Because if you're making 1 or 10 or even 1,000, it's going to be vastly cheaper. In order to justify the cost of a casting, you need to make tens of thousands, hundreds of thousands, maybe millions. So so that gives Tesla a unique advantage because they have casting in-house. Nobody else, maybe Hyundai, has any expertise in casting. And what I imagine they would do is even with a fairly small press, 4,000 tons, they could put all the pieces they need to make an entire bot into one injection. And so that it would pop out in what would look like a model airplane parts, where it's all plastic and you just break them off, where all the parts could be done in a single shot once they get it actually done. And so they've got a huge advantage there. And the other guys would look to move to that, but then they've got to go back and re-engineer. The weight distribution is going to be a little different. They're going to have to retrain the AI from there. It's a big mess that they've got. And in terms of the robots that are actually going to be running the assembly line, because again, the other guys are looking at, well, can we build it on stations? Can we build 100, 1,000 of them? It doesn't make the sense to design it the same way for that as it does to scale it up necessarily. So their Tesla will be looking from day zero at making millions. And so the assembly line will be automated. The robots used to build these devices, these appliances, these robots are the smallest, cheapest robots out there because they only need to be able to lift 30, 40 pounds, as opposed to when you need a robot like I saw at the factory tour yesterday. Some of those robots can lift 10,000 pounds. That robot
Mhm.
has a lead time of a year to get, where these smaller robots are ones that you can just order. They are mass
Yeah.
produced items. And so they've got the assembly line in that they can set up quickly, the castings in ways others don't. And then, like Scott was saying earlier, the the supervisors, the engineers, the people doing the the desktop work are right there on the floor. As you go around Fremont, you will see the cubicles within the assembly space, within the manufacturing space, because it shortens the time from a thought to implementation, and it makes the feedback loop much quicker. And nobody else seems to be aware that this is how it's done or how it needs to be done. In Detroit, you've still got the ivory towers that aren't even in the same city as the factory. And if you want to go down and see what's going on the line, it's 30, 40 minutes away, as opposed to look over your cubicle wall and see what's going on and ask, Tom what he's working on.
Or
So
even worse, it's a
big
it's a
advantages all
it's a
around.
plane trip. Yeah. So it's inconvenient
Oh,
to get those.
yeah.
Yeah. It's yeah, it is never a walk across the street. It's really is minimum getting in your car and having to drive at least an hour to see it, as opposed to I
Let's
just need to check this thing out for 5 minutes, go over, oh, look at that, go back to your cubicle.
let's talk about the other
Yeah.
robot manufacturers, and let's compare them and then find out what they might need to do. So this is a table that Søren Basher, Scott, and I, and John Gibbs have created. We have a company called Human Bots, and we're a consulting software company. So what we're doing is comparing all these bots. The ones in light blue are bots in North America, in Europe, in the West, and then these are the Asian countries in the red here. And the kind of ways we're looking at is comparing whether or not they have a commercial focus or they're research based. And if they're commercial focused, are they walking? Do they have hands? Have they shown a demo where they can do useful work? Do they have an integration with voice and LLM? Have they been able to demo autonomous work? This is going to be updated now because just in the last few days, we've seen a bunch of these guys, Unitree, Fourier, they've all shown autonomous work as well. Have they announced a pilot? And so this is where it just boils down the small, much smaller at this point, the list of companies that have announced the pilot. I think Fourier also announced the pilot, and they're out there too. So we need to update this. But the question today is deploying the bots. It's one thing to create a pilot. It's one thing to create a bot and do demos. Can they actually manufacture it? And so earlier in this show, we were showing all the job openings and the hundreds and hundreds of people that Tesla has hired, but the others have not shown that in their job openings. It's still very much, engineers to create the bot or AI to help give it intelligence. So what would Figure need to do to create a factory? We know that Agility Robotics, Digit, they've already announced that they have a 10,000 per year bot factory that they're building now in Oregon. I think we know that Sanctuary, right? They have a partnership with that Canadian auto supplies partner, right, Scott?
Yeah, one of their partners is Magna,
Mm-hmm.
which could be interesting. Now, Magna was also the company that was producing the Fisker, and
Okay.
they usually produce lines for other companies to build their product, but they can also sometimes build their own lines and produce their own production parts. But for the most part, they are the ones that build the lines for other people to run, and they could have the knowledge base to be able to manufacture this as well as wanting to use the product themselves. So that,
Yeah.
in some ways, if you're going to find which company is kind of close to Tesla in that sense that they've got a partnership or someone that potentially internally would want to use it, well, Sanctuary is definitely one of them. And as well as we brought up like Boston Dynamics potentially because they're owned by Hyundai. But outside of that, everyone else is sort of on their own to figure out how to manufacture these things at scale.
Yeah. Figure announced a partnership with BMW. Aptronic announced a partnership with Mercedes. Now these are just pilots, and they're gonna use
So
them
be
there.
careful.
But
I'm not sure. Would we call it a partnership or we call it kind of a pilot? That's what's kind of hard on the language
Sure.
because sometimes a partnership might mean that much closer association that you'd be thinking of longer term cooperations as opposed to what we
Well,
hope will be a good long term customer.
yeah. Aptronic, they actually showed their bot with the Mercedes logo on top of it. But
Mhm.
I guess my point is that, they're picking partners.
Or it might have been Mercedes showed the Aptronic bot with their logo on it. I think they were the ones that really wanted to make sure that logo was on.
Yeah, that's what I meant.
Yeah.
Yeah. But I guess what I'm saying is that, if these are the first sites where they're going to do a pilot, they possibly could help manufacture it because that's what they are. BMW, I mean, they're assembly companies, but
I do want to
So-
point something out on that. You will see a lot of videos from different automobile manufacturers showing the production lines. And it's really rare that they show their logo on the bots. So you'll see these bots going around, you'll see like a Kuko logo on it or a Fanuc logo or something else, but you won't necessarily see that company's brand on there, even though everyone will know it's associated with it. So it was rather interesting to see that when Mercedes, and of course, they're the ones that were publicizing the Aptronic, they made sure that their logo was front and center on there. Now, a lot of people looking at that might have thought, oh, it's the Mercedes bot. And no, it's not the Mercedes bot. It's the Aptronic bot that is actually being put into a pilot at Mercedes. But it's somehow that Mercedes has realized that, whoa, we want to be taken serious on this thing. And so it was a really interesting choice because a lot of these companies are they're very careful about how their logo is used. And the idea of putting your logo on someone else's product, I think that says a lot. And trust me, it wasn't just like some engineer put it on there. It kind of went up to different levels of people saying that you've got to get the sign off on that before we allow you to release that with our logo on someone else's product.
So I wanted to address something you said, Scott, about Magna. And a lot of people haven't heard of Magna, but they are huge. They are an auto parts manufacturer, but they go beyond that. They do a lot of engineering. I had a chance to talk with a Magna engineer at CES, and they were showing their Gen 1 electric drivetrain systems and their current generation electric drivetrain systems. And they couldn't say who the manufacturer was, who the brand was, but it's an SUV made in sold in North America, but made in Europe. So of course it's a Fisker. They do a lot of the engineering. They were taking on a lot of that role on behalf of Fisker. They have fantastic engineers, and they are a company of sufficient size that they have tremendous amounts of money. So when they see a benefit in something like this, it is not crazy at all to think that they could move forward on their own, whether in partnership or just start from nothing, because they would be able to use the bots themselves. They'd be able to learn from the engineering on it. And then for that matter, you've got the big opportunity there is that they're involved with everyone. If they can make the actuators, they can make it work. A question I would have for everyone, and this is something you guys can help me understand, is who else has the compute? I saw it in the questions Charles was asking, who's got enough compute to actually get it up and running, get the brain functional?
Yeah, that's going to be a good question. I think just to finish off the thought, Brian, is Magna is probably the biggest automobile manufacturer that you've never heard of. And like I say, they pretty much build the lines. They just don't run it. They don't design the cars. And in some cases, they will build the cars like they did for Fisker. And I think there's some other examples. They are a huge conglomerate. They are considered a Canadian Austrian company. Okay. Some people will say it's a Canadian company. Some will say it's an Austrian. It's both. It's big. They have stuff all over the world. And if you are a heavy manufacturer and you need to have someone do the integration of everything, chances are they're going to be in the top of your list of one of those companies you're going to go to design it and then build it for you. So yeah, they definitely have manufacturing expertise.
So your question about who's going to build the AI, but I mean, we just covered this yesterday. Um, Nvidia partnered with at least 12 bots. They had 10 humanoid bots flanked around them, and all of these companies have partnered with Nvidia. They're going to get the chips. They're going to get the training platform. Now, in terms of AI, at least two of these companies that we were looking at here, they partner with OpenAI, right, Scott? So
Yeah.
um,
Yeah. So again, the AI has been considered a potential moat. So when you think of a moat, you think of the classic thing that you have your castle with a moat around it, and you're trying to keep a defender from coming in. And so they can't cross your moat. But what if that defender decides to come up with an alliance with 10 other companies? Then suddenly, that moat may not be as impenetrable as before. So what we've seen with Nvidia right now is that all these companies are saying, you're right, we cannot go toe to toe with Tesla, but we're going to put together the Grand Alliance, I think as they call it, and see what we can do to take down Napoleon at Waterloo. So that might be what's going on here, is that you have a lot of companies coming together and recognizing we know how to build the robot chassis. What we don't know how to do is to get the compute. We don't have access to compute. We don't have everything else. But if Nvidia is putting together some sort of platform that they can begin to develop on, and they all can start using it, and this is something that occurred to me yesterday when we were talking together, Herbert, is the idea that potentially, if you were able to solve the task for one of these bots, you might be able to transfer it from that bot to the other one, even though it's a completely different form factor. Not from like a human to a dog, but if you've got two humanoid bots that are very similar, doing a very similar task, it may be possible that when you start to finally get success with that one, it's able to move into the others. And so if they're a partnership, depending upon, the agreements between all these companies, it might be, yeah, we're going to basically raise all of everyone's capabilities simultaneously, or not. We'll see.
yeah, so let me just summarize what you're saying there, Scott, just so everybody's back on track here. So some of the ways that you think that bots are competing with each other, right, is how advanced are they in creating the actual hardware? We had spent the first half of this call talking about that. You need to get something that is manufactured at scale, designed for manufacturing. Then the second thing is you need the AI, the intelligence. And then the third is you actually need the actual manufacturing. You actually have the
Yes.
skill to do
Yes.
that.
Yes.
Okay.
Yes.
So in terms of the skills, the all these other bot companies, at least 10 of them have partnered with Nvidia. And what you're saying is that, because volume matters, right? How
Mhm.
many you create and how many are out in the real world, interacting with the real world, because you can use all the training, the simulation training, you can do the teleoperation training, you can do the video training. But then you need as many bots out there physically interacting with the world to really reinforce it, to really get better.
Yes.
Tesla, because of their manufacturing capability and their AI built inside, they can actually create very many of these really quickly. We'll talk about how many we think they can do, but it's not a stretch for us to think that they'll make 1,000
Yeah.
next year, or hundreds or 1,000 next year, and maybe 10,000 the following year, and then eventually millions, because they can do this. These other companies, they need to partner to create manufacturing. And like Digit said that they have a 10,000, a factory that they're building, it's going to take them several years, can make 10,000 of these per year. That may not be enough. But if they combine with all the other 9 partners and they have all these bots out there, they can then maybe get enough that actually and share the real world experience.
Exactly. That's the idea. So, FSD, the success of that was the fact that there was cameras on Teslas, and it was able to gather all that data. But you didn't necessarily have to put those cameras on Teslas. You could have put them on lots of other vehicles, and then you would have got even a larger data set. So it may be the same thing, that as more and more of these bots are going out in the real world. And if you kind of look at this is something that I kind of noticed that someone else, I think it was Chris Paxson, also noticed that the physics there was not quite perfect. You'll notice
This
when it
Digit?
went down to stoop, Digit, when you
Yeah,
notice it
let's see
stoop
it.
down in front of it, that its
Yeah.
knees actually were on the floor and not its feet. And they were up there. So that shows that the physics capability is not only is always perfect, and it's actually floating for a second there, which is kind of odd. So it gets the contact point kind of right with the back part of the knees. But then it's getting some of it right, but it's enough to allow it to, let's say, make those first tentative steps in the real world to figure out what's going on. But what's even more impressive is the Unitree backflip demo.
Hold on.
I don't know if
Before
you
you
have
move
that.
on, let
Yeah.
me just explain to people what we're sort of seeing here. This is the digit that's designed for pick and place. It's doing a pilot in Amazon. They're the ones that we've been talking about that has a plan to create a factory in Oregon, 10,000 bots. And you can see that they've designed them to be very simply designed. They're, very different. They've got the knees going backwards because it allows them to pick. On the left screen here, that's simulation. This is Nvidia
Correct.
allowing you to simulate in a simulated world how we would do it. But once it does it, it can then do it in a real world, which is the thing on the right. And that's where you're saying that in simulation alone, it helps and it's obviously it's effective, but it's the physics, like you're saying here, may not be perfect. And that's why
and you need to get the
real
physics
world.
perfect, right? You want to get the physics perfect. So I don't know enough about how they're doing that model. I was really kind of surprised to say, well, wait a minute. It seems like the contact points and everything there, that they should have that nailed down. I'm not sure why that's off. So it makes me wonder how much the rest of the model is just looks nice versus what might be the realistic data that you need to be able to train on. So there's probably enough to train on, but not quite enough to get perfection. And that's why you would deploy it in the real world to then be able to refine the model to make sure it actually is able to walk better. But what it does is it gives you a really good first shot at it, that you're very close to the solution. And now you can just iterate with the mechanical hardware, because to get to that state required so many iterations, so much testing, you could not possibly do that with a physical bot. So you need to do it with a virtual bot. You do that for as much as possible. You can also look at the Unitree example today that they showed doing the backflip, which was amazing. And so what they did is something similar that Boston Dynamics did is Boston Dynamics, when they were trying to figure out how to do the parkour, they were testing it also in simulation to figure out what it was that they had to do, except they were kind of working out heuristically what it had to do. In this case, they went in with the physics simulator and just worked on backflips until they figured out exactly what did you have to do as far as throwing the arms and everything else. And that is just physics. But what you'll see, even though they got that was like a perfect landing, right? The real bot misses the landing. It sticks it with its toes and then stutter steps and come in there. Now you might say, oh yeah, it's not so good. That is impressive that their control system was unable to recover. I mean, so I think that's why I bet they had one that was perfect. And it's just like, no, let's show the one where he stutter steps, because that shows the reality of the difference between you can simulate that and what happens, and are you able to recover? So it gets you like 95% of the way. And I think most of us would agree we can figure out how to do these tricks, and we never quite land it right, but we still stay up on our feet. And that's why you want to get as close as possible. However, you put that thing out there and just guessed what it had to do, it'd be falling on its back all the time, because you're trying to figure out, how do I master that? Exactly how fast do I have to come around? How do I use throwing my weight around like this to be able to get myself in motion? And that's something that that's why you want to simulate. And the AI, you could simulate a lot of that heuristically, where you could have someone go in there and try to figure out the algorithm and work on it. And it's very, very tedious. The idea of the AI is it's like, oh, don't worry, just hand it to us. We'll go through all that tedious stuff with all the iterations and then do the details for you. So you don't have to think about it anymore. That's one of the huge advantages of being able to go ahead and use machine learning for that.
So I have a big question for all of you, and that is those 112 job postings we saw last month. What does it mean?
I mean, this to me looks like they are ramping up for, getting closer and closer to mass production of the robot. And so, there's going to be several things that they need to do there. Like you see all kinds of different postings. And so some of them are core technology. Some of them, they're looking at, writing everything down to the drivers for the hardware. They're doing all kinds of stuff with software. They're doing mechanical things for the body. So some of this is continuing to build out the team to really refine the design of the robot itself, both from a hardware and software standpoint. But then a lot of the other stuff that you see there is that interim layer of people that are really working at, okay, now how do we take these things and make them at scale? And I mean, this is really an area where Tesla shines. And, let's think about the difference between the automotive industry knows how to produce things at scale. But if you think about these companies, they have built up to that ability over decades and decades and decades, that they know how to produce. If you say that, okay, Toyota makes many, many more cars a year than Tesla does. So they're a better manufacturer of vehicles at scale than Tesla is. And there's a dimension at which you could say, yes, that's correct. But Toyota hasn't brought a brand new technology to market in that type of scale in a long time. That they are just tweaking at the margins what it is that they are delivering at those large volume levels. And Tesla is an extremely impressive company in their ability to bring like the what a car is radically transformed today versus what it was several years ago. And that is because Tesla is leading in a number of innovative ways. And they've had to do that up and down throughout the stack of what it means to make a vehicle, not only innovating on the technology, but then of, what is a car? And okay, we're going to use batteries now at the heart of this instead of the ICE powertrain. And we're going to do that for the whole car. And we're not going to do it in a hybrid. And we're going to use these special motors that we're going to be innovative on. And then they have to figure out, okay, now we have to do that. And we're going to have to work with partners. Like you have to figure out how to make your make versus buy decisions. What can I trust someone else to be able to provide to that versus what can I make in house? And they do that. And then they figure out how to move that up the scale of things. And so, that's radically different than a lot of people think it's as simple as, and we'll use the Boston Dynamics Hyundai partnership example to think, okay, here's a person who knows how to design a robot that works, and here's another person, and they know how to manufacture things at scale. Those are two separate ingredients. If I take them and I put them together, poof, you have robots at scale. But there's a whole lot of stuff that's over here in the I'm designing the robot thing that impacts, just like, Scott has said, the Boston Dynamics has never been designing for manufacture ever. And so you put them inside of Hyundai, they don't even know how stuff is made, much less how to design for something that is made. And so now there's going to have to be this whole long process of the Boston Dynamics team learning how to work with the Hyundai team just in order for them to be able to do anything together, much less for that thing to be able to be mass manufacturable. And then you have to layer in, okay, now how do we manage our supply chain and do all those things? And that's extremely, extremely difficult. And this is an area that, Tesla has had to figure out how to do all of those things already just to get to where they are with vehicle manufacturing. And so now they're building out that exact ability for the Tesla Optimus robot program. And the Optimus robot program is the only team amongst all the players that has that unique set of backgrounds and capabilities from an organizational standpoint to know how to do fully integrated design all the way down to mass manufacturing at scale of a brand new technological product. And when we looked back at the picture that you pulled up, it had the Model Y, and there were a couple of actuators, and then we've got the picture of the Optimus robot, and it's all actuators. Like the ratio of red on the car to the ratio of red on the Optimus, the Optimus is almost 60 or 70% actuators. And that capability is not something, Hyundai is not an actuator manufacturing company. And so what real benefit does Hyundai bring to the table in manufacturing actuators at scale to Boston Dynamics? It's probably not zero, but it's definitely not a sure thing that they're going to be able to pull that off and bring a lot of value to what this project is going to be between them and Boston Dynamics. Whereas if you look at Tesla, every single Tesla on the road has got multiples of industry leading actuators inside of them. Yes, they're in the form of electric motors for cars, but a lot of that expertise transfers over. And the types of actuators that need to be made are all new actuators. So there's not anybody in the world today who already makes the types of actuators that need to be made in mass for us to have millions and millions of robots. And so, whoever it is that's going to be able to do that successfully has to figure it out from the ground up. And once again, this is a skill set that Tesla really has in-house. And, you can't tell me that this is something that Agility knows how to do, or Figure AI. Like, this is stuff that those are all the hardest challenges ahead of them, are all going to be in this area. And I think the software part of things is definitely going to get figured out. It's going to be figured out kind of in an open source way. A lot of people are going to be able to accomplish the same types of tasks from a software perspective and make it look really good. But can they put it in a robot body that is mass manufacturable and scalable? That's going to be a whole nother challenge. And that's where Tesla shines. And that's what these job openings are looking at. Like, these are the jobs of the people that are figuring out all of those problems.
So I would point out that Hyundai is actually a massive international conglomerate that operates in many different industries. So they've got expertise beyond what we may recognize in the US, since we pretty much only see their cars and maybe some of their shipping containers. Um, I saw a comment that actuators are not rocket science. I'm confident that someone like Hyundai could uh, design their own actuators at yes, there you go, that are very, very good, and do so on a budget that would just disappear into their existing R&D budget because it's already so absolutely massive. That's not to say that Tesla wouldn't have a huge advantage. They started making them sooner, and their experience is in electric devices. So they would, I think not everyone's got all the pieces they need, but Hyundai would be a very strong contender for someone who's got all the pieces.
I think we also have to make a distinction between actuators and motors. Okay. So an actuator is kind of a fancy motor because it's more than something that just spins around. It also has encoders in there that will be measuring the position. So there's a little bit of a control system, and there's probably some kind of gearbox. So they're a little bit more sophisticated than a simple motor. The other thing is we don't necessarily know what's going on in Hyundai, but if you were to take an example of most automotive companies, say, well, look at their cars. They have, even the ICE ones have a lot of electric motors in there all over the place. Yeah. And you know what? They probably don't build one of them. It's all coming from their sub-suppliers. So like, the door openers and for the windows going up and down. Yeah, there's actuators in there, but they're probably buying them, from Bosch or Johnson Controls or a bunch of others. And the real question is, like, how many of those motors do they even make? Like the starter motor, it's like, that's also probably coming from a sub-supplier. So they may actually have no internal experience. And all those motors we're talking about, while they may have similarities to the actuators that are in a robot, are very, very different. So the torque capabilities, the size, everything that you need to have is going to be different.
So a good example of that is when a Jaguar was purchased by Ford. Ford started making Jaguars. Literally, they took the Ford Taurus platform, put a new front and back clip on it to make it look a little more stylish, and used the same 3-liter motor. Well, not quite the same. They replaced the lifters in the engine with basically electronic versions of the same thing. Ford didn't make that part. They just used that part. And it was a fun way to see how that came together, I guess.
Okay, so Scott, I just wanted to show this image because Boston Dynamics, everybody keeps pointing to them still, and yet their CEO has said that this was never designed for manufacturing at scale, and these are not electric actuators, they're pneumatic, and you cannot be co-working with something like this. It was too dangerous for humans nearby. But, just take a look at what they've built here. This is not designed for manufacturing at scale. Can you explain the challenges here?
One is probably just got way too many parts. The precision that might be needed in some of those parts, just like looking at the risk mechanism and everything. A lot of it is very similar to what you see in industrial robot designs, which also can be pretty costly, as well as just the hydraulic systems. That's just another way that you can't scale it down. It's making some of the control a bit challenging because while it has a lot of power, it doesn't have, let's say, finesse that you would like to have in there. And just too many parts and how it comes together. So they were learning that and this is the same thing that Tesla and everyone else, and something that Sandy Munro talks about a lot, is a lot of times you can make one part as one piece. Other times people will make it out of 3 or 4 parts. And then there's like these processes that you've got to put them together. And then from that, you can finally snap it in. So there's just too many operations that are involved in it. So even though the part might seem very simple because they're not manufacturing it the correct way, there's way too many steps, which makes it complex. So those are all the things that go in kind of the design for manufacturer is, there's design for manufacturability, which means, yeah, we can build it. It's physically possible. We're not asking for a sphere that's hollow. We are actually talking about something you put together, and then, really being able to design for manufacture at scale. And that's sort of the missing piece.
Yeah. So as I flip through the different kind of robots, it sure looks like that not only did we look at Boston Dynamics, this was Figure. I mean, they're getting close, but they still have those, things hang, the big giant wrists. They have the wires still going around them. They still have a giant backpack for the batteries. This is Digit. I think they look like the most ready because they're so slim. But they're very, very focused on just pick and place, specifically in a factory. So that's what they were designed. And this is Aptronic. Also looks pretty good. Very slim and looks pretty good there, right? I mean, let's take a quick look here. But they still have their wires sticking out. So it won't take them long, right? These guys, probably another gen, and then they'll get there. But simplicity of design is where they have to get to before they can even start talking about manufacturing.
Yes, and we'll probably be looking more and more at Aptronic in the future. It's a very innovative design in that it uses almost exclusively linear drives, whereas what you're seeing here, the Unitree bot, is using almost exclusively rotary drives. So, the elbow mechanism, you can kind of see that down there, how that's working. But even the wrist or the shoulder up there, of course, the wrist, the Tesla is using that kind of mechanism for the wrist as well. But the shoulder is actually all being actuated by linear drives. So
why does that matter?
Well, that's a good question. I mean, they all kind of study that, in that it could be that there's a lot of manufacturing. There seems like a certain degree of extra complexity by going to linear drives, but they give you a certain amount of torque and other capabilities. They also tend to be more energy efficient. So they're something like 90 to 95% energy efficient as far as being able to take the energy you put in and turning into mechanical energy, versus a rotary motor, which actually is a little bit more lossy. It's around 70%. So that was kind of a surprise that I learned about. I didn't realize it was that much. Whereas if you look at the Unitree, you see everything there is a rotary actuators right down in the knees and also on the hamstrings. And so if you look at the Tesla bot, you'll notice that those are all linear drives, because the linear drives can give you a lot of torque when you need it. Whereas in many ways, it's almost easier to build something out of rotary drives in your knees and your elbows if you can do it. And that's the design challenge. And this is the arguments that go on in the design room on whether we should be using a linear drive or not. Now, the Unitree, while they are using rotary drives, there are some mechanisms in there that look a bit linear. So if we're able to freeze it, we'll see that in the legs. You have up there, way up where the calf muscle is a rotary actuator, but it's connected to a connecting rod that goes down to the heel to give you the same kind of differential motion that you need on the feet, just exactly like the Tesla bot does. But the Tesla bot, since we need to have these push-pull rods going on there, they go ahead and use a linear drive for it rather than taking it from a rotary. And that's the approach that some of them are taking, is you're taking a rotary motor and turning it into a linear, whereas in other cases, you may be taking a linear to ironically create a rotary action. But the thing is, if the rotary action has to take place away from where you're actually doing the actuation, because you need to, if you want to have your wrist in your ankle be very slender, you don't want to build the actuator at the joint, because if you build the actuator at the joint gets very big and swollen. So basically your joint is very simple. It's just a simple pin, right? You don't need very much, but you need something to be able to push it. And so if you can put that thing up here far away from that, but now you have to worry about being able to get force at a distance to actuate it on down there. And one way is have a push-pull rod, or you do it with hydraulics, right? And that way with hydraulics, you put some on. Anyone that's seen a backhoe knows, where's the power from that backhoe arm come from? It comes from the diesel motor that's also used to drive the backhoe around. That diesel motor just is running a pump, and then you can pump that stuff through. So that way you can get action at a distance with hydraulics. That's the beauty of hydraulics. But then there's other downsides to it. So when you do the actuation, if we could come up with like a really tiny actuator that had tons of torque that was like the size of a door hinge, wow, we would have everything solved. Okay. You wouldn't need all this stuff, but you just can't get it that compact and get it on down there. So I can have my wrist and my elbow actually be kind of slender. There's a reason why the muscles, if you want to call these muscles, are kind of back here and away from it, is that they take up the volume and the space there. So you can have a much smaller kind of elbow for movement. And also the same thing as far as the wrist movement. And if you look at the figure robot, you'll see it has a really swollen wrist. So they're going to have to change that design eventually. And the Aptronic, you'll see it's got no problem because it says, wait a minute, you get space back here to stick those linear drives in. They're just there. Let's use it. That's our space claim right here. I don't want the space claim down here.
So you agree, right? I think almost everybody would, that Optimus Gen 2 is way ahead, or at least ahead of all the other robots in terms of design of the hardware.
Yes,
correct?
it definitely looks, and also for
then
manufacturability.
We've shown also that Tesla has been hiring hundreds and hundreds of jobs for the Tesla bot for manufacturing. And so far, we've not seen any of the other bot manufacturers hiring for manufacturing at this point, except for maybe Digit.
Correct.
Who's announced
the only
that they're
thing I
creating a
would
factory.
caution is I'm going through that list. There's a lot of things that's robotics, but it doesn't necessarily mean Tesla bot. I mean, some of them said they're Tesla bot, so it's like, okay, it's for that. But there's a lot of others for automation because they're also doing other things internally that may be related to it for just a manufacturer. So it's hard to say how much of it is for manufacturing of the Tesla bot, how much could be thinking of how to integrate the Tesla bot into manufacturing processes somewhere else, and how much of it is just getting the Highland ramp up going and automated in Fremont.
Okay.
But if it says Tesla bot, because a lot of them said Tesla bot, and then they were looking for a manufacturing engineer or testing engineer. Then
you can see the highlights.
Yeah,
the highlights is bot.
But then you'll see some that don't have Tesla bot in the description. But okay, like ones. If you stop there, we see autopilot and robotics, but we don't see Tesla bot in there. So I suspect it has nothing to do with Tesla bot. But it has to do with the robotics that's going on elsewhere within Tesla, because believe it or not, they do a lot of robotics in Tesla.
Yeah, but I think that's the point, right? The point was in just a few months ago, Tesla changed their career page and combined AI and robotics into one thing. And so everything they do for Dojo, everything they do for autopilot, everything they do for the cars, which Elon's referred to as, bots, they're bots in the form of wheels. It just happen to have 4 wheels. So you mean like they all work together. And that's one of the massive advantages that Tesla has, is that they've already been doing this. They've already been creating bots. They've already created the real world AI, the vision cameras, and then, having supercomputers and so forth. And then the chips and the latency of the chips, right? And inference computers in the cars are the same inference computers you have in the bots. So they have that advantage. And then, of course, they're the only ones that have actually manufacturers at scale, unless you partner.
Yes. Yeah, exactly. And
anything
the other
else?
thing is they I think one of the other advantages is that they have almost an unlimited supply of resources within Tesla. As far as what do they got, 30 billion in the bank now? Of course, they can't just throw all that at the Tesla bot, but there's a lot of other areas that they're spending that. But they don't really have any problem of lack of funds to keep this going. And then there's the others, is they could be getting payback sooner than everyone else. So as soon as it becomes usable inside of Tesla, it's already affecting the bottom line. And when it's doing that, then you can start saying you've justified it. But until the other companies are able to get it out in a reasonable scale to their customers, and their customers are actually paying them for that it may be a long time before they get that cash flow that's able to kind of keep the company going without having to do additional rounds of funding. So that's, again, one of those inner moats. So there's several moats everyone has to be able to pierce to be able to kind of get in. And I'd say that they still have a couple. Manufacturing is a really big moat to kind of get over. And then the other, of course, is just the fact that they ain't going to run out of cash. They'll be fine for quite a while.
One of the other pieces that it actually touches on is a conversation that Scott and I had with James Dauma about 8 months ago, that, every single piece of robotics equipment that exists inside of Tesla could be improved by the addition of smarter software and potentially some additional sensors in the form of cameras. And you can bet that this is not, I mean, this is an opportunity that is not lost on anyone who does anything in the robotics field. I'm sure Scott could agree with that. But Tesla has a much higher than average amount of expertise and experience marrying those two things together. And it's an opportunity, that's like low hanging fruit that just is all over the ground inside of Tesla for them to put people to work on improving the ability of intelligent AI powered software to be involved somewhere in the operation of these robotics in order to improve the overall efficiency of the factory. And, over time, that actually has an impact on design as well as the scale and the actual manufacturing methods that get used. And so they've got this whole tightly integrated feedback loop that is able to not only make better products that are more scalable, but better factories that are more efficient, that make things more scalable, that make things faster. And it just like goes around in this big flywheel circle. And the tighter that you have that overall integration, the more cycles you can get around that flywheel. And that is one of those areas that Tesla is just far and away really out in front of any other company that I'm aware of.
Yeah, and I would agree, Hans, that I wouldn't be surprised if some of those positions we're seeing there are to tie the AI more into the overall manufacturing. And it had been brought up before that, could this FSD kind of technology be used for the standard industrial robots? And I was like, yeah, absolutely, should be able to happen. But if you look at what some other companies have been doing already, and especially I think it was Covariant AI last week, they put out a post just before Figure came out with the one, and everyone started talking about that one instead. But they were showing it for industrial bots, how they have this huge repertoire of training sets of robots doing picking and placing that they've been working for years, and say, you know what? Now we can just train industrial bots the way we're seeing that they're talking about training the humanoid bots. I was expecting that to come. I just didn't expect it to come this soon. So again, a lot of the surprises, I mean, Brett had the same problem with it. He didn't think the AI would be ready for his bot. And now it's like the AI is ready for his bot and his bot's not quite ready. It's the same thing. So that's going to happen. And just to say that, Hans has absolutely hit the nail on the head.
So we have covered the advantages that Tesla has for scaling manufacturing, but we have repeated this several times that all these humanoid bot companies, the market is so massive that we don't actually see them as competitors with each other. The challenge for them is to go through, design the bot hardware, get an AI that actually can train to do useful work, and then get manufacturing at scale. And they will all be able to do this. And maybe not all, many of them will fail and many will go out of business. But the ones who can will sell their bots and be able to do very well. They're not going to compete with Tesla. But just the point about Tesla seems to have everything in place, including manufacturing at scale. And you can see that they've already started hiring. They already got the Gen 2, which is very close. We're going to hear at some point that this is design locked, maybe sometime in the end of this year or something like that. And then they can start moving faster. So thank you guys very much. We've got Brian from Future Aza. You got Hans from Hansi Nelson. And thank you, Scott, for joining us. Couldn't have done this without you. Appreciate it, everybody. See you soon.
Thank you.
Bye, everybody.